Good morning. Our presentation is about mapping potential targets for gold mineralization. We are from the Federal University of Rio de Janeiro, Brazil. I am Luiz Braga, and my partners in this research are Cláudio Porto and João Casado. The presentation is divided into 5 chapters: Introduction, Methodology, Results, Validation, Conclusion. Results of geochemical exploration surveys in deeply weathered tropical terrain should be carefully treated and interpreted as they are affected by a strong modification of the primary geochemical signals at surface. This is particularly relevant when soil samples are used as an exploration sample media, making it difficult to locate potential targets for gold mineralization, relying on geochemical assays for gold in soil samples. This problem is especially important in the Amapari region, Amapá state, Brazil, where the humid tropical conditions contribute to develop regolith profiles that may be several tens of meters thick, topped by lateritic crusts or highly leached colluvial soils. In Figure 1, the geology of the area is shown schematically in the locations where most of the gold deposits have been identified. The units of iron formation that hosts the most deposits are highlighted, as well as the locations of the soil grids: A. Background, B. Mineralized, and C. Validation. The data is composed of a vast soil multi-element geochemical survey conducted in the region. A training step based on mineralized and non-mineralized area is essential to select the best geochemical variables to be adopted in a balanced formula whose score will be calculated over a validation area. It is based on the data mining methodology. Although no data mining package is used, the essential steps of the SEMA sample, explore, modify, model, access paradigm are followed in this work. This methodology was created by SAS Institute, is supported by its tool SAS Enterprise Miner. In the first step, samples are selected and partitioned. Exploring the data implies in exploratory data analysis. Modify the data means to transform the data in order to allow model building. Modeling is the heart of the process. It may be a classification, a prediction, or an association model, and access corresponds to the evaluation of the model. Geochemical data can be considered compositional data if the different elements forming a subcomposition are expressed proportionally. As a consequence, it's possible to transform geochemical data in compositional data to build geochemical maps which represent such elements in proportions. In Figure 2, the basic steps of the methodology are presented. 1. Sampling of the mineralized, background, and validation areas. 2. Compositional exploratory analysis. 3. Best discrimination balance BDB determination. 4. Plotting of the BDB index in areas A and B. 5. Evaluation of the BDB map vis-à-vis areas A and B. If approved, plot the BDB map for area C. Otherwise, return for sampling refining. 6. If approved in area C, the selected BDB may be used for ulterior prospection in the region. Otherwise, the method is not applicable. In Figure 2, it's shown the workflow of the methodology, from the sampling up to the prospect validation. Violet boxes denote action, lozenge boxes denote decision, and colored boxes denote the samples. The analytical results of soil samples used in this paper represent part of a soil geochemical dataset produced during the exploration programs for gold mineralization in the region, where nearly 15,000 soil samples were collected and analyzed, covering an area of more than 500 square kilometers. The samples were collected according to sets of northeast-southwest oriented grid lines which show a slight difference in the direction between them. The space between samples along the grid lines varied from 20 to 160 meters, while the distance between lines varied between 100 and 1,000 meters. These samples were analyzed for 51 chemical elements. All analysis was performed by the Chemex laboratory in Canada. Data analysis and maps were carried out using several packages: the computing language R, the geographic information system ArcGIS, and the composition analysis was achieved mainly with the package compositions. Traditionally, a dataset has been compositional if it provides portions of a total. The individual parts of the composition are called components. Compositional data scale, however, can't be treated just as a concatenation of several separate scales for each variable. A compositional scale is a new multivariate scale. We have opted for the Atkinson composition scale, a comp. The sample center is a value of central tendency of a compositional sample, that is, the closed geometric mean. It's defined as center or compositional mean. The variation matrix describes the dispersion in a compositional dataset, whose matrix is tau. The smaller the matrix variation element is, the better the proportionality between the two components. The center log ratio transformation is often used to open closed data. It is an isometric transformation between the simplex and the dimensional real space. This means that we can translate virtually anything defined for real vectors to compositions. A balance between two groups of parts, M1 and M2, is a measure of the total relative importance of one or more metals, group 1, against the other metal or more metals, group 2. And the measure of contrast must be a log ratio, and its value is a balance score. It is a balance that best discriminates between two states, given Y, a dichotomous response variable, a composition X. The goal of the algorithm is to determine two subcompositions of X so that the balance between them is highly associated with Y. For a dichotomous variable Y, we fit the logistic regression model. ROC curve means receiver operating characteristic and is the convex hull of the pairs FPR, TPR of each balance on the ROC plane, where the coordinates are the false positive rate and the true positive rate, calculated for each partial optimal balance. That is, the score calculated by each balance for each sample point will place it on the mineralized or non-mineralized class. A pathfinder in geochemical exploration is a relatively mobile element that occurs in closer association with an element or commodity being sought, but which can be more easily found because it forms a broader dispersion halo or easily analyzed in the laboratory. This broad definition of pathfinder element can be extended to the compositional approach. The bar plot is a form of showing the variation matrix. For each metal, the column shows the corresponding value for each variation matrix element. Each segment in the column corresponds to an entry in the metal variation matrix. Each segment of the column corresponds to a variation in each metal as exemplified for the case of boron, arsenic, aluminium, and silver in the gold variation matrix column. As it is shown, gold has the largest variation values with the other metals, that is, higher non-proportionalities, which emphasize the difficulty to map a gold prospect in the area, as fewer options are left to compose the balance. The package cell ball was used for the samples from areas A plus B, including a target variable assigned to each sample. The BDB between the two groups was the balance silver, arsenic, antimony, uranium, mercury, indium over vanadium, iron, sulfur. The results are summarized in Figure 5A, which depicts the score box plots for samples A and B of the selected balance. On the upper corner, the receiver operating characteristic curve, the true positive rate and the false positive rate axis, and the calculated area under ROC curve, 0.99. The denominator prevails over the numerator, that is, elements associated to background A and opposed to gold prevails over the elements associated to mineralized area B. But it's clear that on area B, although it's not positive, in most samples the scores are greater than those in area A. Therefore, this balance will be adopted as the result from the training step. In order to validate the methodological approach used in this paper, area C with a similar geological setting was chosen. This area has also been surveyed with a soil grid with the same sampling and analytical procedures, except that it has been more densely sampled. However, the associated gold grades were below detection limit. The results of the balance score values in the three areas are shown in the same plot. It can be noted that the mineralized area B is dominated by high balanced scores compared to the background area A. In area C, it can be noted a trend of higher score balance values following an east-southeast direction, which coincides with the location of the three new gold occurrences detected in its extreme corner side. The proposed method was successfully applied to highlight a mineralized trend in the Amapari region, which was not previously detected, considering only gold grade or any other potential pathfinder metal alone. Given similar geological conditions and with the lack of a distinct signal by the assayed gold grades to indicate mineralization, the method may be of use in other regions and may be adapted to accommodate other valuable metals. Thank you for your attention.